right, so we're going to try these four. These four are from the textbook. They're from section R, and in section R, they are numbers 1, 3, 5, and 7. And that's why you don't have to do those for homework, is because we're doing them together. So I decided to do the odds because they got increasingly hard. So I didn't do the first 4 easy ones and left you with the last 4 hard ones. So in order to find the directions on it is to use the first derivative test to find the relative extrema. Okay, so the first derivative test, I'm going to have the first derivative. So the first derivative of the first one is 4x minus 4. And I want to know when my first derivative equals 0. So I'm going to set my first derivative equal to 0. So that tells me that my first derivative is equal to 0 when x equals 1. So I'm going to go ahead and make a sign diagram with 1. And the first time I made this video, I made a mistake in that I was trying to take these numbers for the sign diagram and substitute them into the original function. And that's not what you're supposed to do. You're supposed to put it back into the first derivative. So it might be useful for you to go ahead and label this, because eventually we're looking at, and even last week we were looking at sign diagrams for the first derivative and also the second derivative. Remember, we looked at velocity and acceleration. So it's probably important that you label each one of those. So anyway, I'm going to go ahead and substitute a number less than 1. So I'm going to use 0 into the first derivative. So 4 times 0 minus 4 is negative 4. So that's a negative. And a number greater than 1 is 2 that I'm going to use and substitute in here. So 4 times 2 is 8 minus 4 is a positive answer. So because I go from a negative to a positive, I can tell that this is actually a minimum. So I have a minimum at 1 when x is 1, but in order to find the y value of the minimum, I need to go back to the original function and substitute that x value in. So I get 2 times 1 squared, that's 2, minus 4 times 1, minus 3, so that gets me negative 5. So that one's not so bad. If I go on to number 3, again, not too bad. Okay, number 3, I'm just going to do the power rule here to get the first derivative. Okay, and the first derivative here is 5/3 x to the 2/3. Okay, so 0 equals 5/3 x to the 2/3. I'm going to multiply both sides by 3/5, so that gets me 0 equals x to the 2/3. And I'm going to raise both sides to the 3/2 power. That's how I'm going to solve this. So x equals 0, basically. All right, so when x equals 0, I'm going to figure out if I have a sign change, okay, by putting numbers into my first derivative. So if I put a negative number, that's what's down here, into my first derivative, I'm going to end up squaring it. That's the main thing I need to see right there, is that I'm squaring it, because once I square it, it turns the negative to a positive. And I'm multiplying by the positive, so that means this will be a positive. Okay, and when I take a positive number and I put it up here, and I take a positive number and square it, it's positive. Take the cube root, it's positive. And multiply by a positive number, it is also positive. So in this case, I have no sign change. So no sign change implies no relative extrema. Okay. All right, so for this one up here, now we get into more difficult ones. I'm going to change color a little bit because this red is getting to me. All right, so I have to find the first derivative in order to find the relative extreme points. So to do that, I'm going to have to apply the product rule. I see a product of 2 functions, so u is my first function and it is x, and its derivative is actually 1. And v is going to be the quantity x plus 3 cubed. In order to find its derivative, I have to apply the chain rule. So the 3 comes down as my coefficient, x plus 3. I reduce my exponent to a 2, and I multiply by the derivative of the inside, and the derivative of the inside is just 1. Okay, so now I can apply the product rule. Okay, so that's going to get me x times 3 x plus 3 quantity squared plus 1 times x plus 3 quantity cubed. Now I got to do some manipulation here to actually get it into something that's going to make sense for factoring it. Okay, so I can see that this is actually a 3x here. Okay, but I also see that I have an x plus 3 to the second power in both of these. So that is a common factor. So I'm going to pull that out. X plus 3 to the second power. When I pull that out of here, all I'm left on this one is a 3x. And if I pull out a squared over here, the 1's not going to make a difference because I'm just multiplying by it. So what I have left is an x plus 3, right? So x plus 3 that I'm adding. Okay, so that means in factored form I've actually got x plus 3 quantity squared and 4x plus 3. That's my factored form. So setting that equal to 0 is much easier. X plus 3 squared. That's the hard part in this question right here. If you picked up on the product rule and the chain rule, is actually figuring out how to manipulate it so that I can set it equal to 0. If this was a calculator problem, it wouldn't be an issue because I could just graph it in the form I came up with and find the x-intercepts. Okay, I'm not even waste my time trying to get it in factored form. But if it was not a calculator question, I would have to get it in this factored form. So anyway, in the factored form, I can see that my x's are going to equal -3 and -3, that as multiplicity, but I'm only going to list it the one time, and -3/4. So on my sign diagram, I'm going to have a -3 here and a -3/4 here, and I'm going to test numbers in between. Okay, so if I test, for instance, -4 and put that into my derivative here, -4. -4 plus 3, that's a negative number, but it squares it. So this term is always going to be positive. So really the only term I need to test is this one here. So if I put a -4 in here, this becomes -16 plus 3. That's a negative number times a positive number. So that should make that a negative. Okay, if I test a number in between, say -1. Again, it doesn't matter because this is going to turn positive, but -1 here is going to be -4 plus 3. That is also negative. And if I test a number above -3/4, say 0, this is still going to be a positive. This will be 0 plus 3, so that will be a positive. So I will get a positive value there. So what I'm looking at here is I have no sign change going over top of -3. So it's possible that that's a point of inflection that we'll see next time. So I know it's not a relative extreme point though, but I might have this relative extreme point here at -3/4. I'm going from a negative to a positive, which means I have a minimum. So here I have a minimum and it's going to be at -3/4. And when I substitute that back in, I've already substituted this back in my calculator and gotten a value for it. It's an obnoxious one, but you can check my work. It's -2187 over 256. Now, absolutely, you could write those as decimals with 3 significant figures, and that would be acceptable. All right, so let's try the next one. So you could apply the quotient rule here. I don't really like the quotient rule. I tend to screw up the order of them with that subtraction in there. So I actually chose to rewrite this function as x plus 1 to the -2, and I'm going to apply the chain rule. So for my derivative, I get -2 x plus 1 to the -3, and that's being multiplied by the derivative of the inside, which is 1. And now if I rewrite that, I see it's -2 over x plus 1 to the 3rd power. Well, the only way that a fraction can equal 0 is if its numerator equals 0. But this will never equal 0 because there's no variable in the numerator. So because there is no variable, the first derivative never equals 0. Okay, but we do want to check. We saw this in the warm-up basically. We do see that we have undefined. It's undefined when x is whatever makes this 0, which is -1. So it's undefined at x equals -1. But there is no There is no sign change because there is no 0. So that means that there is no relative extrema. If I had made a sign diagram on this thing, I would have to put this -1 on there, but I would put it as an open circle because it's an asymptote. And if I wanted to test some numbers and put in like -2, -2 plus 1 is -1 cubed is negative, that would be a positive. And if I tested 0, that would be a positive, and that would be a negative. So there is a sign change, but it's not a sign change where x equals 0. So therefore, there's no relative extrema here.